Hey, algebra students. In this lesson, we are going to be talking about parallel and perpendicular lines. A really important lesson that is not too difficult for you to do, but you really have to pay attention because we're going to be dealing a lot with the slopes of lines. So, all of the slope concepts we've learned in the past, yeah, they're coming back in this lesson, and you are going to be expected to work with them fluidly. All right. Let's get started by just defining what parallel lines and perpendicular lines are and talking about some of their properties. Parallel lines are lines in the same plane that do not intersect each other. We would say that parallel lines have the same basic direction, or they point in the same basic direction, so that they travel in the same direction, but they never touch, never cross, no intersections. All right. Let's just take a look at what it says about the slopes of parallel lines. Two non-vertical lines are parallel if they have the same slope and they are not the same line. So that means they have to have two distinct equations that can't solve to be the exact same equation. They have different y-intercepts. That's another way of considering parallel lines. They have to have different y-intercepts. Um, but they have the same slope. That's key. They have the same slope. So if we solve for the m in y equals mx plus b, parallel lines will have different b's, but the same m. Different y-intercepts, same slope. And then lastly, any two vertical lines are parallel as long as they're not the same line. Okay, so let's just look at the example. Y equals 2x plus 7 and y equals 2x minus 1 have the same slope, 2, but different y-intercepts. So that's why they're parallel. Perpendicular lines similarly have slopes that we can determine are perpendicular. But now this is tricky. There's two things you have to remember here. And I have even students in Algebra 2 and geometry who sometimes forget to do both of these things, all right? Any two lines are perpendicular if their slopes are negative, that's the first thing. Reciprocals, that's the second thing. They have to be negative reciprocals of each other. A vertical and a horizontal line are also perpendicular to each other. Now let's take a look at these slopes. The slope of y equals 3x minus 7 is 3. Think about it. If the slope of one line is 3, what does the slope of the perpendicular line have to be? The negative 1/3 reciprocal. Okay, the slope of y equals negative 1/3 x plus 3 is negative 1/3. Since the slopes are negative reciprocals, one is negative, one is positive, one is 3, one is 1/3. If the lines are negative reciprocals, the slopes are negative reciprocals, that means that the lines are perpendicular. All right, let's do some lesson practice and work on these concepts. Okay, letter A, we need to just determine if the equations represent parallel lines. So let's see. Y equals 2/3 x plus 5 and 1/3. Well, I noticed that we have the same number multiplying x, except it's the reciprocal. It's 3 halves x plus y equals 1. Well, here's what we need to do. We need to get x over to the other side of this equation so that we could see what it is. So let's see. Y equals, and let's see. I'm going to subtract 3 halves x from both sides. I'm going to get this in a slope intercept form like this one, and we could compare the slopes then. If I subtract 3 halves x from both sides, I'm going to have negative 3 halves x plus 1 on the right on this side. Okay, so this equation is y equals negative 3 halves x plus 1. This equation is y equals 2/3 x plus 5 and 1/3. They're not parallel because they would have to have the exact same slope. When I put them both in slope intercept form, I realized this one has a slope of 2/3. This one has a slope of negative 3 halves. They are, in fact, perpendicular lines, not parallel, because the slopes are opposite reciprocals. All right, letter B. Write an equation in slope-intercept form for the line that passes through negative 3, 2 and is parallel to a line with the equation y equals 4/7 x plus 5/7. All right, now here's the thing you need to do with a problem like this. We are going to just throw every part of the equation we're given out of the window, okay? I'm just going to, anytime, down, letter D, same thing. We're going to throw every part of this equation down here out of the window except for the slope. We don't care about the rest of this equation because the only part of this we need is the slope. So we're looking for a line that's parallel to this one. What is the equation of a line that's parallel to this one? It's going to be y equals 4/7 x plus b. It's going to have a different y-intercept, same slope, okay? Now I need to find b because I can never leave b as a variable. I can leave x and y as variables. I have to leave x and y as variables. I can't leave b as a variable. So what do? I'm going to have to plug in an x, y, okay? Do I have an x, y? Well, I have the point that it passes through. -3 is an x and 2 is a y that's a solution of this line. So I can use that to figure out b. What this is going to be is 2 equals 4/7 times -3 plus b. And all I did was I plugged in this point as an xy point to this equation. All right, let's finish solving this one. So if I simplify this, 2 equals, I'm going to multiply 4/7 times -3. I just multiply the numerators, right? It's going to be -12/7 plus b. -12/7 is 1 and what is this? It's going to be 1 and 5/7. I'm going to add 1 and 5/7 to both sides of this. That gives me 3 and 5/7 equals b. So now my equation for the line that's parallel to this line, but let's see, passes through the point -3, 2 is y equals, I have to have the right slope, 4/7 x, and the right y-intercept, plus 3 and 5/7. I'm just going to make that 26/7 as an improper fraction for clarity there. And that's my answer. All right. That equation, hey, why don't we just verify that by going to good old GeoGebra? And we're going to start a calculator, and we're going to start an algebra calculator, algebra. Okay. And let's just enter those equations and verify that they are perpendicular. So one equation is y equals 4/7 x plus 5/7. Y equals rise over run 4/7 x plus 5/7. Okay. And now my parallel line, y equals 4/7 x plus 26/7. Y equals 4/7 x plus 26/7. All right, now let's just make sure this passes through the point that it was supposed to. This says it has to pass through -3, 2. 1, 2, -3, 2. Well, would you look at that? -3, 2 is a point on this line. It's parallel to the other line. Oh, I did it. Okay, letter C. Determine if the lines passing through the points are perpendicular. They would have to have inverse, negative reciprocal slopes. So there's this set of points and there's this set of points. Now, what am I going to do? I'm going to do the slope formula. M equals y2 minus y1 over x2 minus x1. This is a rise over run equation, okay? Y2 is -4 and y1 is 2. So -4 minus 2 over x2, that's 2 minus -2. So let me just, 2 minus -2. Okay, so let's figure this out. So I see I have a double negative here. -2, 4 minus 2 is, so this is going to be -6 over 2 minus a -2 is 4. So, or -3/2. Okay, that's my slope for my first line. Now let's do my second one. This is going to be m equals, same thing. Let's just write it out. Y2 minus y1 over x2 minus x1, and let's plug in what we got. Y2 for the second line is 3, and y1 is 6, so 3 minus 6 over, and then x2 is 5 minus 3. X1 is 3. Okay, what do we have here? 3 minus 6 is -3. And let's see. We have -3 over 5 minus 3 is 2. Oh, -3/2. The slope of both of these lines that pass through these points is -3/2. That means that the points that pass, or the line that passes through these 2 points and the line that passes through these 2 points are parallel because they have the same slope. They are not perpendicular. All right, letter D. Write an equation in slope-intercept form for the line that passes through -1, 3 that is perpendicular to a line with the equation up above. So it's going to be the exact same problem as up above, except now y is going to equal -7 over 4x plus b. How do I know that? Well, before the slope was 4/7, right? Now I need the perpendicular line, which is going to have the opposite reciprocal, -7 over 4. Has to pass through -1, 3. So let's plug in -1, 3. 3 is my y equals uh, -7 over 4 times -1 is my x plus b. Well, that's just going to change 7/4 to positive. 7/4 times -7/4 times -1 is just 7/4. 7/4 again is 1 and 3/4. So I'm going to subtract 1 and 3/4 from both sides. 3 minus 1 is 2. Minus 3/4 is 1 and 1/4. 1 and 1/4 is the same as 5/4. So B equals 5/4. Now, if you don't believe me, go ahead and check me on a calculator. But when you subtract 7/4 from both sides, you should get 5/4. Keep in mind, 7/4 is almost 2. So I'm subtracting almost 2 from 3. So that's going to give me something really close to 1. 5/4 is almost 1. So every way I do this, it makes sense. All right. So my overall equation, y equals -7/4 x plus 5 over 4. That's an equation perpendicular to y equals 4/7 x plus 5/7, and it passes through the point -1, 3. All right, and finally, letter E. Use the slopes of the line segments to show that ABC is a right triangle. All right, there's many ways to do this. I'm going to do this the easiest. I'm just going to count rise over run. All right, so if I look, so we're trying to figure out that this is a right triangle. And if I was going to guess the right angle, this is acute. Angle A is acute. Angle C is acute. Angle B is the only one that could possibly be right. To make sure this is right, I need to make sure that these two lines are perpendicular. If they're perpendicular, they meet at a right angle. So let's check with the slopes. This goes, line AB goes down 3 over 1, 2, 3, 4, 5, 6. Down 3 over 6. Okay, that's the same as -1/2. Line AB has a slope of -1/2. Now let's take a look at this other one. This goes up 1, 2, 3, 4 over 2. This has a slope of 4 over 2, which is +2, which is really 2 over 1, right? Opposite reciprocals. So we would say that AB has a slope of -1/2. BC has a slope of 2. And because the slopes are opposite reciprocals, they are perpendicular. That's how we do that. All right, you are ready to work the problems associated with this lesson. Have fun.